So let's come to a first question. A bedding plane had a true deep of 45 degree. So theta will take the true deep. It is given 45 degree. Then a section is caught an angle of 60 degree to the strike. So let's take this will be our strike direction. Then you know the true deep direction is always perpendicular to the strike direction. So this will be the true deep direction. In this direction, the deep is given 45 degree. Then a section is caught at an angle 60 degree to the strike. So this is a strike direction. So from any direction you can take. So we'll take from this direction, there will be 60 degrees, suppose this much. This is the section. This is the direction of the section, which is caught 60 degree from the strike. So let's understand this. Suppose we have a bed like this. So now it is dipping some here given 45 degree in this direction. Now this will be the strike direction and this is the true dip direction. Then we will cut a section like this, which will be at an angle that is 60 degree from the strike. So this will be, suppose, the strike direction. We will take an section that should be measured 60 degree from the strike direction. You can also measure from this. So this will be the section that is 60 degree from the strike direction. So now you will have to calculate the apparent dip along that section. So now suppose this is the section that is 60 degree from the strike direction. So you have to calculate the dip. So this will be your apparent dip, because perpendicular to the strike, that is your true dip. All other direction, in any direction you will measure dip, that will be considered as your apparent dip, which will be less than the true dip. So now we have a formula for this. That is your tan alpha equal to tan theta into cos beta. So alpha is your apparent dip amount, and theta is your true dip amount, and beta is a horizontal angle between the true dip direction and apparent dip direction. Now this section we have taken, this is your apparent dip direction. Now this will be considered as your beta. So angle between strike direction and true dip direction is your 90 degree. Now this beta is your given, will be 30 degree, because this is 90, now this much is 60, so this much will be 30 degree. So we'll get beta is equal to 30 degree. Now we have theta, we have beta, we'll calculate the alpha. So you can put here tan alpha equal to tan 45 degree into cos 30 degree. So write down here tan 45 equal to 1 into cos 30. You have to calculate. You can use the calculator. It will be cos 30. It will be approximately 0.866. 0.866. So it will be, alpha will be tan inverse 0.866. With tan inverse 0.866 will be 40.89 degree. Will be 40.89 degree. So the dip along this section will be 40.89 degree. So you can also apply another formula, that is tan alpha equal to tan theta into, you will take sine, you will take gamma. So gamma is the horizontal angle between strike direction and apparent dip direction. You can also solve this problem by using this formula. Answer will be same. In case beta is your angle between the true dip direction and apparent dip direction, and we'll take gamma, which is angle between the strike direction and apparent dip direction. To draw a figure for you. So this will be strike direction, this will be true dip direction. Suppose we'll take this is your apparent dip direction. So this angle will be your gamma and this angle will be your beta. So now you can solve this problem. So now you can pause the video and try to solve this problem. So here the apparent dip of a bed is measured along a section making 45 degree with the strike. Now apparent dip, it is measured along a section that made 45 degree with the strike. So here gamma is given 45 degree, then the true dip theta is given 30 degree. So we have to calculate the apparent dip. Same, tan alpha will be tan theta into sine gamma, you can take. So tan 30 into sine 45 degree. So it will be tan 30 will be 0.577. Then your sine 45, it will be 0.707. So alpha will be tan inverse 0.407 contain. It will be tan inverse 0.407, approximately 22.14. So during calculation you can take a whole digit, or you also take 3 digits, or you can also round up them to 3 digits. Answer will be approximately 22.14. Let's move to next question. And also pause and try to solve this. A sedimentary bed has a true dip of 40 degree. So theta is given 40 degree. An apparent dip is measured along a direction making an angle 60 degree to the true dip direction. That means it is given beta. Beta is the angle with the true dip direction. Beta is given 60 degree. Then we have to calculate the apparent dip. First we have to calculate the apparent dip. Then that will be tan alpha equal to tan theta into cos beta. It will be tan 40 degree into cos 60 degree. So it will be 0.5 into tan 40 tan 40 will be 0.839. 0.5 will be 0.419. So tan alpha will be this. So alpha will be tan inverse 0.419. It will be 22.73. This will be our apparent dip. So then if the outcrop width of the bed is given 80 meters, then calculate the true thickness. So now suppose this is our bed which have a dip of 40 degree. We have a dip of 40 degrees. The outcrop width means how much thickness it is making while exposed to the surface. So now that is given 80 meters. Then we have to calculate the true thickness. So true thickness, it is the vertical distance between two layers of bed. So this will be the true thickness, write down T. Now this is given 40 degree. So we have to calculate the T. So the formula for true thickness, T equal to W sine theta. So W is the outcrop width, which is given 80 meter into sine 40 degree. So it will be, so check, 80 into 51.42 meters. So true thickness will be 51.42 meters. So you can easily solve this problem by using the apprendi formula. Then you will use the true thickness formula. So next move to another type of problem which is very important. So it is very important for IIT-JAM. So most of in every year you will find one of these questions. So a mineral exhibit a retardation by refrigerance from which we will calculate the thickness. So first the formula is retardation is equal to thickness into by refrigerance. So thickness, it is the thickness of the mineral specimen. Then by refrigerance, it is the difference between high Ri minus low Ri of a mineral. So if you know the thickness and by refrigerance, you can calculate the retardation. So what is the retardation? So you know, in case of anisotropic mineral, when a ray travel through anisotropic mineral, it splits into two rays. One is your slow ray, one is your faster ray. So the faster ray, it will travel at a greater speed, the slower ray travel at a slower speed. So that will always, the slower ray lags behind the faster ray. So this is called as your retardation, which is symbolized del. So retardation, it is how much distance a slow ray lags behind the fast ray, or you can say fast ray advances from the slow ray. So see, so next question is given the mineral has a retardation of 900 nm. So retardation is given 900 nm. Then by refrigerance it is given, your by refrigerance given 0.030. Calculate the thickness. So we'll calculate the thickness. So you know retardation equal to thickness into by refrigerance 0.30, 0.030. So thickness will be 900 nm, 0.030, it will be 30,000 nm. So answer is asked in nm, so it will be 30,000 nm. It's a very important question. So you can pause this and you can try to solve this. So your asked question in thickness is given in micrometer, but answer is asked in nanometer. So here by refrigerance it is given 0.015, then thickness is given 30 micrometers. So you have to calculate the retardation. So retardation will be thickness into by refrigerance. So thickness is given 30 mu m into 0.015 is your by refrigerance to 0.45 micrometer. So if you convert it, it will be 450 nanometer. So 1 micrometer, it is equal to 10 to the power minus 6 meter. 1 nanometer, it will be 10 to the power minus 9 meter. So 1 micrometer, it will be 10 to the power 3 nanometer. So if you convert 0.45 micrometer, because answer required in nanometer, so it will be 450 nanometer. So next move to another question, same like that, and also try to solve this. So thickness is given 0.03 millimeter here, and the birefringence is 0.020. So we have to calculate the retardation. So retardation will be 0.03 millimeter into bireference is given 0.020. So 0.03 into 0.020, it will be 0.0006 in millimeter. So if you convert it into nanometer, it will be 6000 nanometer. So answer will be 6000 nanometer. So these are the thickness by reference numerical is very important. So you'll find it in each year of IIT-JAM question. So remember, the formula is retardation equal to thickness into birefringence. Sometimes it is the thickness is given in one unit, then it is the retardation asked in other unit. So keep in mind in that. So that's why you have to be careful about the unit. Then next we'll move to another type of question, which is regarding the phase rule, which is your P plus F equal to C plus 2. If it is an isobaric system, then P plus F equal to C plus 1. So P is the phase, that means the number of physically separable unit in a system. C is the number of component, that means number of chemical species, or we can say minimum number of chemical species that are required to define all the phases in the system. Then 2 is a physical variable. Then F is the degree of freedom. So here in a petrological system, we have 3 components and is invariant. Invariant means your degree of freedom is 0. So you have to calculate the maximum number of phases that can coexist. So here component is given 3, F is given 0. We have to calculate the phase. So it is not given whether it is isobaric. So if you see in any question, isobaric is not given. So you will take P plus F equal to C plus 2. So you have to calculate P, F is 0. So C is 3 plus 2, it will be 5. So maximum number of phases that can coexist will be 5. Then same type of question here. During a metamorphic reaction, we have 3 solid phase and 1 fluid phase. So when there is a fluid phase involved in this your phase diagram or phase rule, so first you have to consider whether it is a mobile system, that is open system, or closed system. If it is given in an open system, then fluid phase will not be considered in component and phase. If it is a closed system, then it will be considered as a component and phase. Open system means any type of, you can say, metamorphic reaction that is going on within a rock or something that has to be porous and permeable. That is called as an open system, where the fluid phase are in mobile phase. So in that case, you will not consider them as a component, but in closed system, you have to consider them as a component. But if it is not given any either of the system, so you will take fluid as a component and phase. So here in metamorphic reaction, there are 3 solid phases. That means phase, we have 3 solid phase plus 1 fluid phase. That means we have 4 phases. Then if the system has three component is given 3, so we have to calculate the degree of freedom. So equal to P plus F equal to C plus 2. So phase is given 4, degree of freedom we have to calculate, then 3 plus 2, so degree of freedom will be 1. Degree of freedom will be 1. If any case, if there is not given whether it is a mobile phase or it is not given in open phase, open system behavior or closed system behavior, we'll take the fluid as a phase. Then during residual metabolism, the following reaction takes place. We have chloride plus quartz equal to garnet plus H2. So now we'll have to calculate the degree of freedom. So first we have to derive the components. See, it is a closed system. So in closed system we have to consider the fluid as a component and phase both. So I have chloride, quartz, garnet and H2O. So how many chemical species we require to represent all the phases? What are the phases? Chloride is a phase, quartz is a phase, garnet is a phase, and fluid that is H2O is a phase. So chloride, it has MgO, MgO is oxide in chloride. Then chloride has SiO2, which also define quartz. Garnet also has MgO and SiO2. So the components are, you can say, we'll take MgO or FeO or MnO. All are considered as a single component. To reduce the number of components, we'll consider all the patterns, they can easily replace each other. So MgO, FeO, MnO, they can easily replace each other position. So MgO, FeO, MnO, they all are considered as a single component. Then SiO2 will be considered as another component. Then garnet also has MgO and SiO2. Then we have H2. Now these are the number of components you'll find in these reactions. So component will be 4, phase will be your 1, 2, 3, 4. Then it is a closed system behavior. We'll apply the phase rule, P plus F equal to C plus 2. So phase is 4, degree of freedom we have to calculate, component is 4, so F equal to 2. So in a metamorphic system, remember when C equal to P, F equal to 2, this is also called as your mineralogical phase rule. So in this type of numerical, in most of the questions the components are given. If it is not given, so you have to derive from their formula. So you have to choose the oxides which can represent all the phases in the system. So next, move to another question. It is from your porosity. So you know porosity, it is the number of pore spaces within a rock. Then you can calculate the porosity by taking the volume of pore space by total volume into 100. Now see, we'll see what is given. So rock sample has a total volume is given. Total volume is 500 centimeter cube. Then the volume of mineral grains, that is volume of mineral grain, it is given 365 centimeter cube. On saturation, the sample holds 95 centimeter cube of water. That means volume of water in saturated condition is given 95 centimeter cube. Calculate the porosity and degree of saturation in percentage. So total volume is given 500 centimeter cube. So remember, total volume always equal to volume of voids plus volume of mineral grain. Total volume is equal to volume of voids plus volume of mineral grain. Suppose this is a rock sample and these are the pore spaces. These are the pore spaces, and other the part are suppose the mineral grains. That means the total volume will be volume of these pore spaces plus volume of the mineral grain. Now total volume is given 500 centimeter cube. Volume of voids we have to calculate. Then volume of mineral grain it is given 365 centimeter cube. So volume of void will be 500 minus 365 centimeter cube will be 135 centimeter cube. So now we have volume void. Sorry. So now we have the volume of the voids. We have the total volume. So we can calculate the porosity will be volume of void by total volume into 100. It will be 135 divided by 500 into 100. So it will be 27%. Will be 27%. Now we have calculated the porosity. Now we have to calculate the degree of saturation. So what is the formula of degree of saturation? So the degree of saturation is equal to volume of water divided by volume of voids into 100. So volume of water it is 95 that, and volume of voids is 135 to 100. It will be 95 by 135. It will be 70.37%. So it will be the degree of saturation. So next on to another problem. That is also the calculation of porosity. So here a dry rock sample weighs 1.20 kg. So weight of a dry rock will take 1.20 kg. When fully saturated, that means fully saturated means all the pore spaces are filled with water. In fully saturated condition, remember the volume of water will be equal to the volume of voids. So in fully saturated condition, we'll take like this. Fully saturated, it will be 1.38 kg. So the density of the water is given 1 gram per cc, and the total volume of the sample is given 600 centimeter cube. So we have to calculate the porosity. Now we have a formula of porosity, that is volume of water divided by total volume into 100. So this volume of water, it represents volume of water in fully saturated condition. Fully saturated condition. In that case, volume of water will be equal to volume of voids. So now it is given fully saturated condition. So the rock sample in completely dry condition, it weighs 1.20 kg. 1.20 kg. And in fully saturated condition, it weighs 1.38 kg. Now the weight of water, it can be calculated by weight of sample in fully saturated condition minus weight in dry condition. So it is 1.38 minus 1.20. So it will be 0.18 kg. In gram, it will be 180 gram. Now this is our weight of water. Okay. So, but we required volume of water. So this is the weight of water that is present within the rock in fully saturated condition. So now we have density of the water, we have weight of water, we can calculate the volume of water. We know density of water is equal to weight of water or mass of water divided by volume of water. So volume of water will be weight of water, that is 180 gram divided by 1 gram per cc. So it will be 180 centimeter cube. Now we have volume of water, we have total volume. Now we can easily calculate the porosity. So porosity will be 180 divided by 600 into, it will be 30%. It will be 30%. So always remember that one thing, volume of water is equal to volume of voids when it is fully saturated. That means If you see some question ki rock is saturated with this much of water, that doesn't mean it is fully saturated. Saturated means ki the pore space is not completely filled. It is only the volume of water is equal to volume of voids only when the rock is completely or fully saturated with water. Let's move to another question. A sandstone has a porosity. Here porosity is given. So porosity is given 22%. So the total volume of the rock is given. Total volume is given 450 centimeter cube. So you have to calculate the volume of voids. And then we have to calculate the volume of mineral grains. So volume of voids and volume of mineral grains. So this is volume of voids, this is volume of mineral grains. First, we have formula porosity equal to volume of voids divided by total volume into 100. So porosity is given 22% and we can write down 0.22 equal to volume of voids. It is your, we have to calculate then 450. So volume of voids equal to 450 into 0.22. So it will be 450 into 0.22. It will be 99 centimeter cube. You know total volume equal to volume of mineral grain plus volume of voids. We have total volume 450 cc. Volume of mineral grain we have to calculate. Then volume of void we have calculated, that is 99. So volume of mineral grain will be 450 minus 99. It will be 351 cc. 351 cc.